My name is Anis. So today I will be telling you about how to display TCNT register value on LCD and how to display that whenever our timer overflow flag has been overflown. So as you can see over here on the Proteus screen, this is our LCD and this is our 80 mega 328p, and this is potentiometer and power supply and ground. So now I will show you the code. So here is the code through which we will be displaying that when our timer has been overflown and when our registered TCNT value on the screen LCD. So first of all, I just made a function named void delay. After that, you can see this is the int main body of the program, in which I have just declared the initialize the LCD. Then I have declared the port B as an output port because I have been taking output from the port B on the Proteus, as you have seen already. So after that I have put the condition while, for which this will keep on running forever. It will never breaks because I want to tell you that the value of that TCNT again and again and how much time does it overflow. So over here I just declared the repeat after variable on the port, and after that I have called the delay function that I made. So it's simple LCD clear command, so it will display that timer have overflown. After this display function will be executed. So in the delay function you can see that I have just assigned the value to 0 to TCNT. Okay, it's a timer 0 registered, timer 0 on which we are doing the code. So now I have declared TCCR0A as a normal mode of operation of the timer, and I will set TCCR0B as 1, so it will be a normal clock selector, no prescaler. So again I have just cleared the LCD, and now this command, actually this command will be printing the value of the TCNT register, the counting from 00 to 256 milliseconds. So after that I have just put the delay, so we can see actually the value of the TCNT on the LCD, and after that delay it will just check the condition. This condition is actually telling us that if our overflow flag has been set or not. If our overflow flag has been set, then these commands will be executed, which will tell us that our TOV0 flag has been overflown, and after that we will just set our clock to 0 no more, and then we will reset our over flag, and after that these two commands will be executed, which will tell us that our timer has been overflown. So let me debug it first. So it has been debugged, so it's mean it will be working properly. So now as you can see that, now let's upload the hex file. Okay, this is the hex file. I have uploaded it. Now I will just simulate it and you will just see it. So as you can see that our timer has been overflown, so it's telling us no, the reason that there is no now the reason that we couldn't see any value of the TCNT register on the LCD is because it was for such a small interval of time, like for just few milliseconds. That's why we couldn't display it on the LCD, but it has told us that the timer has been overflown one time and TOV overflown. So now I will tell you about our second task. Okay, let me cross it first. Okay. Now this is our program of the second code. Over here you can see that I have just included the library of the LCD, and then this is the library of an interrupter. Then I have declared some variables because the second task was to make a digital clock on the by using timer and display it on LCD. So over here I have just make a function which will be displaying number on the LCD, and in LCD data write I have assigned 0 because I want to write on this LCD screen. That's why I have assigned it a value of the 0. Now after that I have checked I have put in a check. If a is equal to 0, then it will write on the LCD. Otherwise, it will just divide it the number and convert it to the into hex number, and then it will display that last two numbers on the LCD. This command will display the last two numbers on the LCD. After that, I have made an other function to initialize the timer. Over here, I just initialize the timer one, TCCR1B, which have been set into the CTC mode, because we know that in timer there are many types of mode, which is one is normal mode, then CTC mode, phase mode, PWM mode. So I'm using the CTC mode, and after that I have set the clock selector as a one mode with no pre-scaling. Okay, now after that I have made an other function to initialize the interrupt which will be telling us when the seconds have passed, the minutes and the hours. And after that, you can see I have initialized one global variable, and then I have used an interrupt for the 1A register. After that, in the code, you can see I have made a subroutine of the timer, and in it I am just checking that if our check is equal to 1000, then set our check to 0 and put a second plus plus. Basically, you know that 1 second is equal to 1000 milliseconds, so the time in our timer is of in milliseconds. So that's why I am checking that if our timer is equal to 1000 millisecond, then set or second increment or second, so it will make our second one. And over here I am just putting a check to look at that if our seconds are 60, then increase one increment in the minutes, because we know that 60 seconds is equal to 1 minute. And similarly I am checking over here minute and incrementing the minute. When our minute will be less than or equal to 59, then it will set or R1. And similarly I am incrementing or up to 24, because we know in one day there are 24 hours. So this is the main body of the function in which I have just called those function. You can see that over here I am just initializing the LCD, then I have initialized the clock. Tick tock is the command to initialize the clock on the LCD. Now I have given a delay of 1000 millisecond, basically 1 second. So we can see clearly that when 1 second is increasing on the screen. Now I again cleared the LCD screen and put a delay of 1 millisecond. Now I have called the function of the timer interrupt that I made above, and similarly I call the second function to initialize the timer one. After that I am just comparing the value. Okay, the value that will start our timer from 1 millisecond. Now this is the while condition which will keep on running these commands forever, and our time will keep on getting displayed on the LCD screen. Now let's first debug it first. Okay, as you can see it is debugged. Okay, so now we will go on the Proteus, and let's go to the PC. I will just put a hex file in it. Okay, this is the hex file. Now I will just open it, and okay, and I will just start simulation. Now just now over here you can see that this is our second, this is our minute, this is our hour. So now it's been 3 seconds, 4, 5, 6. Now similarly when it will be 60 seconds, it will set minute 1. So I will just stop here. And so these were the two tasks of our lab 5, and I have completed them fully. And if there are any queries, you can ask me freely, and you can ask me the question